purpose of ESA is to design and implement space missions. It has been doing this since the beginning. And for some of the missions also to operate them. Normally the paradigm is to transfer missions for operations to other operators that are focused on specific subjects, like EUMETSAT, an European organization focused on meteo, the collection of meteorological data, EUTELSAT, a European organization focused on telecommunication satellites, and so on. As far as security is concerned, which is actually the subject, the main subject of this presentation, space is becoming a basic element for the security of the European citizens. There is actually a dual trend, a trend from defense on Earth to look at space, and a trend of space missions to be protected from additional threats that are coming from a different geopolitical situation from the ones that we were used to. There is a European security and defense policy which has been formulated at the level of the Commission and the Council of the European ministers, which sees space as a complement for security measures within the surface of Europe. And on the other hand, there is a formulation of the European space policy, which is including a lot of new missions, not only related to defense, but it includes security-related aspects. Okay? Then in the other way, from the spacecraft down to the control center, there is the telemetry, which is providing parameters, values of parameters related to the attitude of the spacecraft, what the machine is doing, and to the experiments on it. Data, parameters of function of the experiment. Then there is the real payload, which is the purpose of the mission. The purpose of the mission is probably to gather data, observational data, navigational data, telecommunications, or whatever. The payload can be sent to the control center, but most likely is the one that gets forwarded to the users, because the purpose of the mission is to do something for a community of users. So this is what we call the payload. It can be scientific, can be applications of any kind, can be observational, can be position. Now we go to the policy side. Before looking at the threats of the space mission, we are tasked to analyze what the mission is doing and how we protect it. So the first thing we need, well, we have a list of things that we need to address when we put up a mission to decide, to make informed decisions about how to protect it. The first thing we need is a security policy, and we'll go through these points one by one. Then we need the security interconnection policy, when we have a mission which is complex with different parties. Then we need a threat assessment. So the third thing we need to look at is what can happen to the mission. Then we need to cope with the threats with the security architecture, with a set of tools that we need to identify and to configure before sending up the spacecraft, and a set of security operational procedures that will describe on a day-to-day basis to those who operate it what they have to do in any circumstance. So these are the 5 elements of securizing a mission. Security policy. For many, the security policy is the boring part because it's the setting of the rules. In reality, it's the most important element to set the rules of the game. Like before playing soccer, you need to have rules to follow and somebody to check that they're properly observed. Otherwise, the thing cannot work. So the mission security policy must be compliant with any security policy of the organization because it has to be compatible with the culture of the organization that is setting it up. But it has to clearly state classification and level of protection of the information associated with the mission. Both live, when it's coming down from the spacecraft, and archived in the archive centers, with the classification of the telemetry, telecommands, and ground system. So, depending on the sensitivity of the data and the level of classification we give it, there will have to be different levels and also different costs in protecting this information. Then define the access policy. Who has access to the system? Who is entitled? So the user community, their roles and their identities. And then the integrity requirements, how important it is that the data delivered is exactly the one that has been gathered, and the availability, the times and the percentages of time that the information will be available. These are the typical parameters of security applied to a specific mission. The security interconnection policy is the one that comes into place and needs to be established when we have different organizations collaborate. Threat assessment, which is the one we'll focus more because it's the most interesting part. It needs to consider the type of mission and what the threats could be to that mission. It is important to consider all parts of the mission architecture during all phases of the mission, as the threat profile will change as the mission progresses. So it is, if the mission lasts for days, that's easy. If the mission lasts for years, it can change the mission profile depending on, for example, the popularity of the mission, so that the data becomes more attractive and so there is more need to protect. Now, the threat assessment will use the outputs of the security policy and the security interconnection document, because it needs to identify potential attacks, and the value of the data is proportional to its classification.